Hello YouTubers. Today I'm going to talk about promises. Now this is a JavaScript object. This video is completely dedicated on promises, and we're going to look into different methods and how we can use promises. Promises is basically used for asynchronous programming in JavaScript, and it's kind of an awesome way to write async programs, provided you know the base core concepts of promises. So once you get the concepts, it's very easy to do kind of asynchronous programming or promise chaining and stuff like that. But currently, as it stands, there is a lot of confusion around promises or how to use promises for the new developers that kind of get onboarded on JavaScript. So let's look at promises. So promises, it's kind of an carry forward from a different language. I think it's from Go, if I'm not wrong. Yeah, some language basically which had promises before, and they thought that it will be cool to kind of introduce promises in JavaScript for asynchronous callbacks and programming. Previously, before promises, callbacks were used heavily, and that was really making your code unreadable, and it was kind of switching contexts and stuff like that. So all that was there, but with promises all that went away. So promises started, they borrowed this concept from there, and then JavaScript, jQuery also had a kind of a similar approach to it. It used to call it as deferred objects, and that is how jQuery was doing it. And then there was this other vendors or other providers who were providing promises object. There was Bluebird API, and that was quite popular for using promises as such. And so finally, when ECMA 6 arrived, right, it had a fully functional spec for promises, and that is what we are going to look at today. We are not going to look at any Bluebird or jQuery promises or anything like that. We're just going to look at the plain ECMA 6 promises that has been there. So the spec is called as promise A plus, promise/A plus in ECMA 6, and it is a very useful and a simple spec as it stands today. So without further ado, let's dive into what is promises. So if you look at the definition of a promise, right, it says that it is an assurance object, right, that a function will execute in the future and will either return a value or an error. So that's the definition of a promise. What it means is basically a function returns you an object which gives you an assurance that it will either execute in the future or return its value, or kind of get into an error, right? So that is what promises. Now promises have static methods, or we call them as global methods if you want, and those are resolve, reject, all, and raise. So these are the four primitive methods that promise has for static methods. If you go to the instance methods, then you have then, catch, and finally. Now all of them we are going to use in our next demo slides, and I'm going to show you how the whole thing works. I'm going to use Node.js in the backend, Node.js, and I'm going to use the promise A plus spec to see how you can execute these methods and stuff like that. So let's jump into the demo now, and let's see how the whole thing works. So in this section, I'm just going to quickly show you how I'm kind of using promises. This is the demo part, and in this you can see on the screen right now that I have opened VS Code. So I'm using VS Code, and I just have one JS file in it, and on the right hand side I have the terminal open. So what I'm doing here is basically just writing a basic class from line number 9 to line number 11, and this is a normal ES6 class, and I've just written some boilerplate code here which says basically console.begin and console.end, and it's just creating alpha as a class instance. So let me quickly run this and show you. So this is what it should look like, and that's the expected output. So we'll just see begin and end, and it does nothing else, and the node code exits. Right. So coming back to writing promises, I'm going to just copy paste a simple bit of code, and this is our first promise function. Now what this does is basically it's a simple function called as simple promise, and it's going to return you a new promise object. Now this is the definition. If you go by the definition of the promise that we kind of looked at in the previous slide, it says it returns you an object, assurance object, which tells you either the promise will get resolved, which means return a value, or it will get rejected, which means it will get into an error, right? So if you look at this function, what I'm doing in this function is basically I'm returning a new promise object. That's my first line, right? Now whenever you create a new promise object, it always needs you to pass in a function. Now that function basically, so I've used lambda function here, or fat arrows, basically that is what you call it in ES6. So I've used a fat arrow and I've taken in two important things. So whenever you create a promise, it needs a function which has two important parameters. One is the resolve parameter and the other is the reject parameter. Now the result parameter is again a function which basically returns the value that you originally want to return from the function, right? So in this case, I'm just returning a string which says return value, right? And that is how I'm calling the resolve part of it. But in case if you want to kind of error this out, you can simply call the reject part of it, which we'll look into a bit later right now. But just looking at the happy flow part here. So if you want to kind of resolve a promise or you want to return from the promise, you call the resolve function and you pass in whatever value you want to kind of throw out of the function. So here I'm passing a string. It could be integer. It could be anything that you are returning an object of, right? Now let's look at how this is supposed to be called and how the whole thing executes. So if I go down to my boilerplate and if I just kind of want to call this function, I would use something like this to execute that. So here is the part where I'm calling the promise. Let's quickly go over it. So this line says basically alpha, which was the instance of the promise use case, wants to call onto the simple promise. Once this is completed, now this is the first function that we are using, then instance function, right? So then is nothing but a way to say to the promise that after you've completed the previous work, do this work, right? Now when you say do this work, it again requires you to pass in a function. Now I've done an inline function here with a fat arrow, but basically what it means is we just console logging the value that was returned from the previous function. Now always whatever you are getting in the first or whatever you are getting in here will always be the return value that was returned by the previous task or previous function that was executed, right? And then I'm just taking that return value and printing it here. So in our case, what's going to happen is your alpha object will call the simple promise function. It's immediately going to return you a promise object, right? It's not going to wait for this to be wait for this promise to get resolved. It's immediately returning you a promise object onto which you are queuing or chaining another promise, which is basically consuming the previous return value, right? Which in this case it will be the return value, the string value here, right? And then it is going to do a console log onto the it's going to do a console log on the terminal. So let's look at this in action. So if I just kind of call this guy again, uh, this is exactly what we want to see. So we start with begin, and then immediately we see end being called. The reason for this being is this function executes asynchronously. Now node is a single threaded application, right? I mean, so to say, theoretically. So it has just one event loop which is working continuously in the background. So the moment it finds some tasks, it executes the task. So currently it is already kind of being queued with different tasks here, which is console.log begin and console.log end. Whenever it encounters a promise, it says that this can be executed whenever the current code yields, right? Or whenever the current code stops, or the current code is not, or is waiting to do something else, or there is nothing more to execute on the current event loop, then it goes to the promise and tries to execute it. And that is how you achieve asynchronicity, right? So that is how the whole thing is being kind of done. So if you look at the output sequence, it starts with begin, that is what console log does. Then it says end, and then it prints out the value which was returned from this simple promise, and prints out using this second then. So this is how the whole thing executes. I hope this all makes sense to you, but this is just the first part of the promise. This is the core concept of promise. So once you get this, the other examples or the other demos would be very simple to follow. right? So that's basically the simple way of calling promises. Now let us quickly jump into the second demo, and that is where we are looking at chaining of promises. We have already looked at one chain here, but let's go a little bit deep and see how we can chain much more complex functions. So for that, I'm going to quickly copy paste a function into the class. So I'm just going to remove the simple function. We don't need it anymore, and I'm going to replace it with something called a chained function. And the way I'm going to call this is I'm going to call this in a for loop, right? So or I'm just going to simply call it right now using multiple then statements. So let me do that. So right now I'm just going to replace this guy out and replace this with this. So don't get overwhelmed with too much of code that just appeared in a second, but I'll walk you through what is happening. So in chained promises, the first function that we introduced in the class is taking in some value. It is returning the same way a simple promise object, right? But inside the function that we passed into the promise object, it is going to set a timeout, right? And in the timeout, it's going to say console.log I was called with the value x, whatever the value is, right? And then it's going to return that value by incrementing the value, right? And the timeout for this thing to occur is described as whatever value you pass in plus into 100 milliseconds plus 1 second. So if you pass in 0, this is like that, the guard for it. So let's look at how the whole thing has been called. So I say alpha and I call the function promise, and I'm passing it the first value to it, right? And the first value is obviously starting with 1. So I pass in the 1 value, and I'm telling next to the JavaScript is whenever this function gets executed, call again alpha dot chained promise, right? So let me just quickly clear this typos that I had. So instead of calling x, I have to call it as alpha. So what am I doing here? I'm queuing again the same promise function back in again and again, right? So I've done this 1 2 3 4 times, right? So what I'm expecting on my terminal window is I start with 1 and possibly I'll end with 4, right? But in a delayed fashion because we have set timeout. So let's quickly execute this and see what's the output. So if I go back and say node promises.js, okay, so that's cool. So what happened here, right? So like always, the event loop executed the begin and the end because they were in one synchronous call, but the promises started after that, and they said that first one was called with a value of 1, which is I think this line number, and then that value or that function resolved, which means it returned a a number which was incremented, right? So if I pass in 1, the result or the return of this function should be incremented, so that will be 2. So that is how the second function got called, right? And then it said that my value was 2, and then the third function got called, then the fourth function got called. So this is how you kind of implement chain. So once the whole thing is completed, then it basically says that my whole my promises or all promises were resolved. Now this also brings us to a promise.all function, which I'll also show you in a later part. But currently what we are doing is we are sequentially chaining promises. That is all that we have done here, correct? There is also another way to look at it, and that brings me to my third demo, right? Which shows you how you can basically, chain promises or use the promise all function. So if in this case, it seems like we were sequentially going in an asynchronous way, right? It is sequential, but it is still asynchronous. You have to remember that in mind. So it is sequential, but in an asynchronous way. What if I have to go parallel and in an asynchronous way, right? So for example, just assume that this guy is not doing a timeout. Instead, it's calling onto some API that I'm passing into a value, right? Now let's say there are 100 API if I want to crawl the web, right? If there are 100 APIs, what would I do? I'll basically put all of those APIs in an array, run a for each loop on them, and then basically wait on all the APIs to get completed, right? So this is where I'm using a parallel operation, and that brings us to our next code, which is basically calling promises in a parallel fashion. So if I just copy paste a new line of code here, I'm going to kind of remove this code and replace it with a better version here. Now this code is actually calling the same child promises, but in a parallel fashion, right? Now, how do you do that? So the function remains the same. What I'm doing here is I'm just creating an array to hold the promises. Okay. Now I'm writing a for each loop. Now this is the part where, let's say if you have 100, whatever, 100 promises to be called out or something like that, then this is where you're going to basically call out, or this is the number of times you want the for each to be run in parallel. So here I'm saying, let's say 10, and what I'm doing is I'm calling the same function alpha.chain promise, which is going to return me a promise, and that returned promise is what I'm pushing into the promise array, right? So in such a way, I'm calling 10 such chained promises, right? But the value here is the index, okay? So it is an incrementing index that's been called. Now, after I've captured all the promises, I'm using the promise.all keyword or all method, which is basically telling me, which basically accepts an input parameter as an array, right? And returns me a promise. Right. So let me show you what has happened. So I have capturing all the promises in an array, and on this line number 27. Once I have captured everything in this array, I'm going to a promise.all method, which tells me that whenever all these promises have completed, then I'm going to execute the return value. Okay, or then you can execute something. So on that, then I've said that give me all the return values of all the iterations that just happened, which in this case it's 10, right? And just log it. That is all that I'm doing here. I hope you guys understand this. This might get a little confusing, but this is the part where you're calling asynchronous thing into a parallel fashion. Okay, so let's quickly jump and see what happens when you execute this code. So I start the code now. Oops, I did not save it. This is where I make a mistake. So I'm saving it now, and then again I'm calling it. Okay. Okay. So what happened? You got called with begin and end, which was expected, and then the promises started resolving because at that time the program yielded from execution. And I can see the promise was called with the value 0, 1 till 9, right? Now, what has happened is the index, which is the line number 27, if you look at it, the alpha was always called with an index value, which means it's an incrementing number. So what it is supposed to do is take that increment, take that index number, increment it by a new value, increment it by 1, and return that one, right? Because that is where we are calling the resolve. Resolve means return this value. Now, if you look at this line, right, which is console.log return print return value, I should be getting from 1 to 10. Now why 1 to 10? Because my index started from 1 and it ended at 9, right? And this guy is supposed to do a +1, which means my return value will always be starting with 1 and ending at 10. And that is exactly what this guy is printed. Now, how this thing whole executed, right? So the way it executed was all the promises were executed. Once all promises were executed, we went ahead and then it printed, or it kind of executed this line, which says console.log return.value, which is this here, right? So what it did was it was waiting for all the promises to complete. Now it is not actually a wait, okay? In JavaScript there is no way you can wait. What it did is it basically queued another promise, which says that after all the promises have been completed, do this promise. So that is all that it did. So promise all is not a wait. A promise all is basically a function which returns you a deferred value or a deferred function to be executed when everything is complete. So the event loop in Node.js was busy executing all the promises. Once all the promises were executed, then it said that execute this promise, execute the then part of the promise, right? And inside then, now since there are 10 functions which are returning individual values, I am expected the return value to be an array of return values of each individual function, right? And that is what has happened here. So 10 individual functions gave 10 individual values. So I'm expecting an array of values here, and that is what I've printed. And this is here the print of that, right? So here you can see I'm getting an array with 10 individual numbers. So that's promise.all, right? There is also something known as promise.race. Now promise.race is, I would like to call it as promise.any. And now I'm borrowing that term from C#, but promise.any is something similar, but the promise object will only wait for a single object. So what it is saying is, I'm passing you a promise.array, right? Now, if any of these promises gets completed, do the next function. Do not wait for all promises to end. Do the next function that is available. So let me quickly show you that. And I'm going to keep the previous one up there so that we can compare the results, right? And if I execute this is what happens. So begin, end, the same one, but then I was called with value 0. This was the first promise that got resolved, right? And as soon as that promise got resolved, we basically got 1 here. What is 1? 1 is the return value of the first promise that was executed, right? So in case of race, this becomes a single value, and the single value is the value that was returned from the first promise that was executed, right? So it did not wait for all the promises to get resolved. It was just waiting for the first promise to get resolved, any of the first promise to get resolved. Once any of the first promise got resolved, it took that as the result and pulled it back into the next then function, and that is what has been logged here. So here you can see the difference. Here it was waiting for all the promises to get complete, and then it returned an array of all the return values from all the promises. In this case, it was not waiting, it was waiting for just one to complete, and it returned the value that was returned from that promise, and it printed that value. And then the other promises were still executed as they will execute because they were already queued, and that is what has happened, right? So this is the promise.race. So the difference between the promise.race and promise.all is basically all waits for everything in the promise to get resolved and then executes whatever is there in the then part of it. The race, however, waits only for the first promise to get resolved, any first promise, and then executes the function that is being provided to it. The other two differences is promise.all returns an array of values because it will wait for all the promises to complete, whereas race will just return a single value as it waits only for the first one to get completed. So that's the difference between the promise.all and promise.race. And that completes most of the part in promises. The only part that is remaining right now is the reject part of the promise, which we have not yet complete, or we call it as catch part of the promise, right? So let me quickly show you that. I'm going to copy another part of the code base here. So I'm going to remove the existing ones so that we have a simple way or less confusion as to how the whole thing is working. All right, and let us see how we're going to invoke this. Now the invoking part is very simple. You just have to call the promise and see if it errors out. So here's the code for the whole promise, right? So let's say I have a function and it takes in a value, right? And it maybe returns some value. And in this case, what happens is even before it goes to return a value, it finds or it encounters an exception. In such a case, we are expected to call reject. Now this triggers the promise object saying that, oh, the function executed into an error or resulted into an error. And whatever you pass in this reject as the first parameter, it will basically return that as the output value or the error value sorry, not the output value, the error value of that function. So if I look at the syntax of calling such a thing, what you do is basically you just call, so the class instance, right? Oh, I missed the class instance here, I think. So let me just declare that again. Alpha equals to new promise use cases. So here is a class instance. So the class instance dot the function name. Now normally you will do a then, right? But in cases when you want to catch an error, you do a catch, something similar like a try catch, right? So you do a catch and you capture that error and capture that error into a function. So catch also requires a parameter which is a function, and it should take one input parameter. Now that input parameter is whatever exception that has been raised or encountered, and though that will be kind of used. So in this catch function, I'm just saying that write console.error, right? Now this can be also clubbed with a then. So for example, I can say then do something here, right? So this is like the return value, and I can say, give me the return value here, or maybe just print the return value, right? So this might be another. So this is how you write it normally. So what you do is basically you say after this is completed, do something else, but you never know that this might return into an error, right? So that is where you write a catch. Okay, so catch basically in a promise chain resolves any error method that has occurred. So it is not only for this, but you might have some error here as well, right? That might also be caught in catch. So let's look at the working of this. So I'm just going to call in the node and run the node thing again. And like you can see here, I just said begin and end, that is as per expectations, and then I got some exception. Now the some exceptions comes from the error part of it, right, which is basically giving the reject part. So in the reject part, I said that this is the exception that I encountered. So it directly jumps to the catch block and says that this is the error that we encountered. So that is where we are doing console.error, and it's giving me the exception part. So it did not go through the then, it basically directly jumped back to the catch block. This is how you kind of do exception or error handling in promise chains, and the catch block is responsible for any error that is encountered in the complete promise chain. So that is how you do error part. So that was a simple way of using promises. I hope you guys enjoyed this. I hope you liked the things, and I hope you can use promises now. If you have any questions or comments, do put them in the comment section. If you like the content, do subscribe to the video, and do also share the video. So that's it from today from my side. Thanks for being. Bye.